talk for the session is by Yugender and Manoj. Yugender is from Tamil Nadu and he's working on analytics of open data from citizen science projects. So he takes citizen science projects and starts analyzing them. And he's been doing this with the backyard Bioblitz during the lockdown period in Kerala. In fact, we've been finding that during the lockdown, the citizen participation on portals have actually increased. And I don't know what, but it's a very peculiar sight that we are seeing all over. Today, he will talk about the key factors for successful identification of a species in citizen science projects. Manoj and Yugender, over to you.
Hello everyone. I welcome all Citizen Science India 2020 conference participants. Thanks to the Biodiversity Collaborative, the event organizers and the sponsors. Thanks for tuning into our presentation. My name is Yugender Subramanian. I'm a software engineer by profession. I have Manoj with me here, the co-presenter. We are going to discuss about some of the less known factors that can help in successful identification of a species in any citizen science project. Identification of a species is one of the first and foremost thing one has to do to study biodiversity of the region and to focus our conservation efforts. There are many scientific and non-trivial things that affects the identification rate, and a lot of those are outside an individual's control, but there are a few other non-scientific and trivial things that a field observer can control in their individual capacity. We are going to look at some of those features which we can control and rather contribute toward as a citizen scientist. For this study, we analyzed the lockdown backyard Bioblitz Kerala project. This is a citizen science project hosted on iNaturalist platform and was curated by Manoj. Methodology we used for this study is we let citizen scientists to report their observations either through iNaturalist mobile app or website, and the community would identify the species in observation. We use REST APIs to download the data, Python to process and find the correlation among the data, and finally Tableau to visualize the data. All the data, the code, and the visualizations are released under multiple licenses and free to use for non-commercial purposes. Please contact us if you have any further questions or if you need access to any of this information. The Python code here downloads the data, and we filtered out any non-relevant data by looking at the skewness in the data. Finally, it lists out the features that are highly correlated to successful identification. Out of the initial 400 features that we took into consideration, these are the 20 finalists that are correlated to a higher identification rate. In statistics, there is a phrase called correlation does not mean causation. What it means to us here is that the features and the identification may not be in a cause and effect relationship. All we are saying is that there is a higher correlation between them. I will talk to some of those and Manoj will talk about the rest. The first is the photo count. Contrary to popular belief, more is not better in this case. As you can see, a lot of successfully identified observations had only 1 or 2 photos, so do not flood the identifiers or the research community with too many pictures. The second is how important it is for one to identify their own observations. Do your own homework, make an as educated guess as possible, because that will help another identifier down the line to either confirm or refine the identification. And third, a lot of observations which were successfully ID'd had geolocation embedded in the images or in the observation. Well, obviously there are some privacy concerns, and for threatened species this could mean a life or death scenario. For those cases, do obscure your geolocations. And fourth, use technology as your ally. Computer vision predictions are not accurate, but use it as an approximation tool to find the closest species. If your citizen science platform doesn't have computer vision features to predict the species, then use reverse image search tools such as Google Image here. And lastly, the taxonomic rank. As you can see here, the most successfully ID'd observations are at the lowest rank, which is at the species level. Try to stay at the species, or if not possible, stay at the genus level. Anything above the success rate reduces. Now Manoj will take over from here. Thank you, everyone.
Hi everyone, it's me again. My teammate couldn't present at the moment for health reasons. Let's look at the next item in the list, that is wiki. Data shows that the species which were ID'd successfully had dedicated Wikipedia page and were integrated into citizen science platform. While some platforms choose to curate their own wiki on the species, there is no preference, and either way it helps with the identification process. The next is the default or reference photo. A picture is worth 1,000 words. When you are shortlisting an ID, it helps to look at a reference photo or an illustration and do a side-by-side comparison with the species under observation. And historically, we have seen that the spatial and temporal records are helpful. There are several reasons why the species under observation in your photo might look very different from stock reference photo. Many species exhibit sexual dimorphism, so their shape, size, color, characteristic, etc. may vary within the same species. The variation might also be due to different life stages of the organism, breeding versus non-breeding, captive versus wild, and in exceptional cases also due to mutation. Interestingly, the variation may also be a result of the changes in the recording device settings, the orientation, occlusion, and weather conditions. Species which had more historical record in terms of both spatial and temporal data seem to have a good chance of identification. And lastly, disagreement. Despite the stigma around disagreement, data shows that disagreements on an ID is not necessarily bad. A lot of disagreements have led to correct ID of the species, and we have to accept it as part of the process. There is a lot of blinded agreement happening in the citizen science community, and if this pattern is left unchecked, can make the whole ID unreliable. So feel free to disagree if you believe that a suggested ID is not accurate. Disagree with dignity and impunity. Some final thoughts. A majority of this study was made possible because of selfless contribution by citizen science community like yourself. We would like to see more and more public, private, and government collaboration in the future. Proprietary or closed data empowers a closed group of people, whereas open data empowers the whole community. We relied heavily on public domain data and information for this study. Democratizing the data helps increase the impact of your work and reach more people. We would like citizen science projects to open source their data, or better yet, upstream to data aggregators and empower the contemporary as well as the next generation citizen scientists. We deeply thank all contributors to public domain knowledge base in the process of preserving and improving biodiversity. If you have any questions or feedback, we are available on the Slack channel. We can also be reached later on the email below. Thanks again for staying with us. Wish you all the best. Hello, everyone. I welcome all Citizen Science India 2020 conference participants.
Thank you very much. Nandini, questions?
Yes. Vijay Barve has a question. How was the accuracy of identifications assessed?
Yeah, that's a very good question. Thanks, Vijay, for asking that question. So there are multiple layers of verification that is happening. So this is basically a community-driven citizen science project. So the community is the first one. Sorry, I'm hearing some feedback. Is everyone?
Manoj, you have to mute, yeah. Nandini, you're muted.
Sorry, that was just the YouTube stream on different people's channels.
I see. Okay.
Event. So yeah.
No worries. Yeah. So the first layer of verification is happening from the community themselves. This iNaturalist platform has a policy where 2/3 of the community have to consent that this ID given is the right one. If not, the identification will walk upwards from the lowest taxonomic level to the one where it converges, and it is agreed by more than 2/3 of the majority. And the second level of verification is done by the curators. Each taxa will have its own curator, and they will come and clean up the identification. But as such, we have seen some people who blindly agree. I know that that's a problem with the community identification, and it's a endemic problem, and I don't think we will be able to get rid of it completely. But we are, as a community, trying to make some modifications to the platform so that making it less and less possible to blindly agree to some identifications. Well, that's where we are.
Right. So Paul Pop has a question regarding the number of pictures versus identification/research grade. Did you compare with cryptic versus non-cryptic species?
Manoj, would you like to field that question? Manoj, can you?
Manoj, you're muted. Unmute and you can answer the question. Manoj?
All right. I think he has he's having technical difficulties.
Yeah, he might be frozen. So.
Yeah. I have to get back to the team on what it means by cryptic versus non-cryptic species. Okay. So I would imagine. Well, I don't want to give any answer that is way off. I have to get back to that question later.
Sure. Maybe on Slack.
Yeah. Sure.
We have another question from Vijay Barve. What was the difference between data posting and data analysis?
Sure. As the first part of the observation is a citizen science who is uploading the data using any method that is accessible to them. For example, it could be a website, or it could be a mobile app. So iNaturalist has provided multiple ways for citizen scientists to upload their observations, and what we have seen is that a lot of people in India, and I think there is a lot of bias in the uploading platform. In India, majority of the observations are coming through Android mobile phones, and that we are seeing some interesting trends in there. And there are very less observations coming from web and the iOS. But what's interesting to watch is that the web uploaded observations are getting a higher chance of identification. It probably could mean that most of the people who are uploading through the web are capturing using a DSLR camera. So they have more advanced techniques to get a better picture of the specimen. So this is giving a better chance of an identifier down the line to come and ID that individual under observation. But as far as the data posting is concerned, the data uploading is the first part. That is the data analysis. A lot of these citizen science platform, they don't have the data analytics part integrated. They do have some very basic statistics that are displayed, but the analytics would require a much more involved effort, and that's where we would need some expertise and like research scientists and coming and filling in this gap, I believe.
Okay, that's really interesting that you bring out the differences between portal uploads. Paul Pop has another question. He strongly agrees that there is a large number of agreement on species just to increase number of identifications on INAT. And he says this is the negative side of the gamifications numbers game. Vijay says thoroughly enjoyed your presentation. But he says he wanted to ask what was the time difference between data posting and data analysis.
Oh,
that was what his question.
Oh, sorry, I misunderstood the question then. So the time difference. So the observation period was from March 21st, when the initial lockdown was announced, up until June 1st, and it's about 2.5 months, I would say, roughly. But the observations themselves may not have happened during that period. They might have been some stock images which the observer took prior to the lockdown, but they just got the time and effort to upload the images during the lockdown period. So the analysis was done a month after the project was done, so which was in July. We started the analysis from mid-July onwards.
Okay, all right. So I think that's all we have for now, and we are getting close to 5 o'clock. I mean, sorry, 3 o'clock. So Prabhakar, over to you. I think you'll have to unmute, Prabhakar.
Yeah, thank you very much for this interesting and exciting session. Lots of questions. The idea of the Slack channel is that you can continue engaging with the audience. You still will have questions posted to you in the Slack channels. Please monitor it and act on it. And if you make larger conversations through the Slack channel, we hope we can increase the citizen participation overall in the country. Thank you very much, and have a good day. Stay safe.
Thank you.
Bye. Thank you very much.
Thank you,
Thank
Prabhakar.
you. Yeah, thank you, everyone.
Yeah,
thank
yeah,
you.
thank you.
So we end this session of talks now, and we end all live streaming till 6:30 today evening, when we have our second keynote talk. This is going to be delivered by Karen Cooper, and the title of the talk is Scales of Participation, Citizen Science to Address Social Roots of Environmental Issues in the United States. This talk, like the morning's talk, will also be on our website. It's a public talk. You can also find it within the Slack channel. So, yeah.
Thank you.
All right.
Bye-bye.
Bye.
Thank you. Yeah. Bye.